Hey guys, did you ever hit a button repeatedly on your calculator like cosine, 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 cosine? Well, if you did, as long as your calculator was in radians, I guarantee it was converging to this number here. And that's what this animation is showing us. So this animation is illustrating the idea of iteration, or where we take an output of a function and we feed it back in as an input. And so here where we see the red line for y equals x, that's helping us visually switch our x and y coordinates. And no matter what point you start with, you're always going to zigzag and converge to what's called a fixed point of this cosine function. Now there's nothing special about the cosine function except that its slope never gets too big, which ensures that we're going to be able to trap that fixed point through this process. For instance, here's another example of a function that has this property. So these functions are called contraction mappings, and basically that means that the slope of the function is never more than 1 and never less than -1. Now my students in real analysis right now are working on homework to prove that any such function will have a fixed point, and this is a pretty challenging problem, and so it came with a lot of hints. And so the first hint was to show that with any starting point that we chose, the sequence we would get by iterating that would always be a Cauchy sequence. And how did that work? Well, I'll put some hints at the end of the video, but ultimately we showed it had a certain property that was related to an earlier homework problem that my students worked really hard on. And so putting all things together, including a little bit of continuity, which you can prove using epsilon and delta, and the contraction condition, we're able to show that this always works. Here's some hints if you want to see more, and let me know in the comments if you'd like to do this homework as well.